Miss Pneumatic here. Today, I would like to talk about a booster cylinder, one of many types of pneumatic hydraulic converters. Let's take a look at what the booster cylinder is and how it works using the animation. What is a pneumatic hydraulic converter? Simply put, it is a device that converts pneumatics into hydraulic pressure to boost the pressure. As you can see from the picture, pneumatic pressure produces less force than hydraulic pressure. When you use this pneumatic hydraulic converter here, you can increase the pressure from at least 8 times up to 36 times by converting pneumatic pressure to hydraulic pressure. Accordingly, even though you do not use a hydraulic system such as a power pack, you can operate a hydraulic cylinder sufficiently with pneumatic pressure. The pneumatic hydraulic converters are largely classified into 3 types: direct pressure type, pre-pressure type, and direct mount pressure type. Today, I will talk about direct pressure types and pre-pressure types. First of all, taking a quick look at the structural drawing of the pressure type product, the converter lies horizontally and the converter and the cylinder are integrated. When you inject oil here, the fluid is filled in the high-pressure tube of the converter. In case of the pre-pressure types, the converter stands vertically and it must be mounted by a separately purchased connector. Now, let's take a look at the driving principle of how the pneumatic hydraulic converter can put increased pressure. Before that, let's take a brief look at Pascal's principle to help understand. Pascal's principle says that given a fluid in a totally enclosed system, a change in pressure at one point in the fluid is transmitted to all points in the fluid, as well as to enclosing walls. The force here is pressure times cross-section, and the pressure is force divided by cross-section. This principle can also be applied to pneumatic hydraulic converters. The principle of pneumatic hydraulic converter increases pressure based on difference between the cross-section of the piston in the closed cylinder tube and the cross-section of the rod. When oil is injected in the pneumatic hydraulic converter, the fluid is filled even to the connected hydraulic cylinder lines. After that, when air is applied to the booster cylinder, the pistons and the rods move forwards and the pressure of the fluid increases. For example, assuming that the air pressure of the 5 bar comes in and the cross-section area of the piston is 50 centimeters squared, we can know the force in the cylinder is about 2,450 newtons as the force equal to applied pressure times the cross-sectional area of the piston. Based on the same theory, the tip of the rod has a cross-sectional area of 1/10 smaller than that of the rear piston. So the cross-sectional area difference increases the pressure by 10 times. Therefore, the first pneumatic pressure is 5 bar, but as the rod moves forwards, the pressure of the fluid rises to 50 bar. Since the actual output theory assumes 100%, it is recommended to select a pneumatic hydraulic converter by calculating it with about 80% efficiency. As a result, the difference in cross-sectional areas determines the rate of increased pressure of the pneumatic hydraulic converter. Looking at the circuit diagram, the pneumatic pressure produced by the air compressor is supplied directly to the booster cylinder with the solenoid valve operated. After that, as the rod moves forward, the pressure of the fluid increases and pushes the rod of the hydraulic cylinder forwards. The hydraulic cylinder moves by the hydraulic pressure in the entire transport section from the beginning to the end. In case of the pre-pressure types, the left solenoid valve works to supply the air and then it pushes the fluid forwards in the converter to make the rod of the hydraulic cylinder primarily move to a certain position. Since then, when the right solenoid valve is actuated, the rod of the pneumatic hydraulic converter moves to the high-pressure tube, boosting the fluid and making the rod of the hydraulic cylinder move forwards as much as the volume of the high pressure with great force. The pre-pressure type converter is used when the pressurization section is short and the high flow rate is required. At the time, it is a working method of moving the rod of the hydraulic cylinder for a certain section with pneumatic pressure and then finally moving it forwards with the hydraulic pressure. The pressure type and pre-pressure type have differences in the configuration of the valve circuits by the driving principle of the increased pressure due to the difference in size is the same. Lastly, let's take a look at the benefits when replacing the hydraulic actuator driven by the hydraulic unit with a pneumatic hydraulic converter. For example, to build a hydraulic system to drive a hydraulic actuator in an environment already equipped with a pneumatic system, vast amounts of cost and space are required. However, when you use a pneumatic hydraulic converter, you can reduce costs with minimal space. It is also frequently used to save energy. When the pressurization time is long or when it is used for a clamp, etc., you have to run the motor continuously or use an accumulator while pressurizing a hydraulic unit to compensate for pressure. However, the pneumatic hydraulic converter consumes little energy even after long hours of use. With these benefits, the pneumatic hydraulic converter has been applied actively in a variety of industries in foreign countries such as USA and Japan. Finally, let me show you how the pressure type booster cylinder really works. Looking at this, you can see a hydraulic cylinder and a booster cylinder. Can you see? This is a pressure type booster that is integrated with an oil tank. In case of a pre-pressure type, you need to buy an oil tank separately. First, we need to inject oil to fill the fluid up to the connected hydraulic cylinder line. To actually inject the oil, you have to connect a lot of devices. I will show you on assumption that the oil were injected. Now, after oil has been injected, air must be supplied to the booster cylinder. When air is supplied, the piston and the rod moves forwards to increase the pressure of the fluid filled in the high-pressure tube. At this time, the pressure is increased due to the difference between the internal cross-sectional area of the booster cylinder and the internal cross-sectional area of the high-pressure tube. Then, the hydraulic cylinder rod is advanced as much as the hydraulic discharge mount in the boosted high-pressure tube. As a result, you can see that the rod of the hydraulic cylinder moves forwards due to the difference in the internal cross-sectional area of the booster cylinder and that of the high-pressure tube. So far, we have learned the driving principle and functions of the booster cylinder. If you have any additional questions, please leave a comment. If you find this video helpful, please give your comment below and subscribe to my channel and click like. Thank you. Bye. Miss Pneumatic channel is working together with KCC Precision.